If the sound emitter and the sound receiver are changing position, somehow the distance between them is either getting shorter or longer, the perceived wave is going to be higher or lower, depending on whether the object is moving towards the receiver or moving away from the receiver. So when we have an object emitting a sound and moving towards the receiver, what happens is as he moves towards the receiver, he lets go of a wave right here, a pulse, and then he gets a little bit closer, releases another pulse, and gets a little bit closer and releases another pulse. And so what happens is those pulses are closer and closer. They're compressed to each other. He lets go of a wavelength and then he moves closer to that wavelength and releases another one. So the distance in between those wavelengths that he's releasing are shorter and shorter. And so the perceived wave has a higher frequency or a higher pitch than if it were just standing still. If it were standing still, it would have a lower frequency or lower pitch because the waves weren't being compressed as it's moving towards it. The exact opposite effect happens when the truck is moving away or the sound is moving away from the receiver. As it moves farther away, it releases one wave, then gets farther away from it, releases another wave, gets farther away from it, releases another. And so the distance in between those waves is stretched and the pitch sounds lower, the frequency sounds lower. So when we have objects releasing sound waves and then moving with respect to the receiver of those sound waves, we can create a perceived higher or lower pitch of that sound because of the motion and the distance in between the released sound waves. This is known as the Doppler effect. The change in frequency or pitch of a sound wave due to the motion of the objects or relative motion of the emitter and the receiver is known as the Doppler effect.